Buckle up, hold on tight, and open your mind throughout this entire video as we dig deep for answers through a head-on approach from every angle and uncover questions around the real reasons for colonizing Mars.
Serious?
What's up, everyone? Hope everybody is doing good, and welcome back to UFO Chaser. So I've been doing some thinking lately and questioning quite a bit on the whole colonization of Mars plans. Why Mars? What's the real reasons behind it? And how come there's such an urgent rush and focus on getting it done as quickly as possible? So in this video, we'll be going over information that I've gathered, try to make sense of it all, and hopefully answer my two biggest questions. Is it really a plan for all of humanity with Mars colonization, or more about the power and control gained by a nation? When it comes to the pros and cons, the bad seems to heavily outweigh the good when it comes to not only getting a person to Mars, but especially when it comes to obtaining a permanent human settlement on the planet. So let's break down the short list on the good side of things about it. Well, first off, Mars' rotation on its axis is pretty close to the Earth's, making the length of a day on the red planet right around 24 hours and 37 minutes. After the Earth, it's considered the next most habitable planet in our solar system. It's been said that water has been discovered in its soil through underground lakes and basins, and in the form of frozen ice, mainly at the planet's polar regions. The gravity is just 38% that of Earth's, and thought to be adaptable by humans. With the low gravity on Mars, you'd be able to lift and move heavy objects more easily. Just a side note though, you might need weights in your boots, because you could jump 3 times higher on Mars. And if you were a person on Earth that weighed 100 pounds, then you would only weigh 38 pounds on Mars. Also, I guess you could say it's not too hot or too cold if you stay near the equator in the summertime, where temperatures can get up to around 70 degrees Fahrenheit. So other than having trace amounts of valuable materials such as gold, tungsten, lithium, cobalt, nickel, zinc, copper, and others, that's about it. That's all the pros, if you want to look at it that way. As a direct quote from American novelist Andy Weir, it would be far easier to colonize Earth's ocean floor than to colonize Mars. Scientists believe that around 3.5 billion years ago, Mars was very similar to the Earth. But that time is long gone, and it seems now all that remains is a desolate planet with its rich red iron oxide surface and dust-filled rocky terrain. So now let's weigh in the bad with colonizing Mars. With that, let's begin by looking at the planet for what it really is. Mars is a small planet. It is around 4,200 miles in diameter, making it about half the size of Earth, that is around 8,000 miles in diameter, and making it only about twice the size of our moon. Mars is extremely cold, with an overall average temperature of negative 81 degrees Fahrenheit. That's over 100 degrees Fahrenheit below freezing. So Mars, on average, is colder than the Antarctic and drier than the Sahara Desert here on Earth. Mars is about 50 times farther away from the Sun than the Earth is, making the planet dimmer with less sunlight. And adding to that, Mars has severe dust storms that can last for several weeks at a time and cover the entire planet, making it nearly impossible to see. The soil on Mars contains perchlorate salt, making it toxic and not suitable for growing plants. Perchlorate has also been found to have a negative impact on humans, affecting the thyroid gland. Something I found really interesting about this is that Mars soil contains perchlorate. Well, get this, it's both a naturally occurring and a man-made chemical. Here's the weird thing about it. Apparently perchlorate is used here in various products, but not just any old normal products. It's used in making rocket and missile fuel propellants, explosives, fireworks, airbag initiators, road flares, matches, and batteries, just to name a few. And I don't know, I just found that kind of strange. So moving on, Mars has no water to speak of, and if there is liquid water, it's extremely salty. Mars has a thin atmosphere, which is about 100 times thinner than the Earth's. Even worse, it's made up of 96% carbon dioxide, with only about 0.1% oxygen. So not only would a human be subject to 50 times more radiation from the sun on Mars, this excessive amount of radiation would cause the human body to develop dangerous cancers. Plus, a human can't breathe on Mars. Surviving only a few minutes, your skin and organs would rupture, outgas, and you would experience a quick, painful death.
Game over.
So now, after weighing out the main pros and cons, let's look at what it would actually take for a human to get to, live, and survive on the planet Mars. So first things first, just getting from Earth to Mars accurately and safely is not going to be a walk in the park. Mainly because the two planets are continuously moving, each in their own different orbital paths around the Sun, causing the distance between the two planets to change. Mars' closest distance to the Earth can be around 40 million miles, with its farthest distance being around 250 million miles away from the Earth. Therefore, making the average distance between the two planets at around 140 million miles apart. So partly being due to this, it can make things a bit more complicated when it comes to the distance, time, and path to your target destination. In other words, it would kind of be like throwing a dart at a moving target. For example, you cannot just draw a straight line and take a direct path to Mars and plan on it being there when you arrive, because by that time, it has moved on. This is why precise calculations must be made when the two planets are properly lined up. This creates a launch window, and according to the calculations, is the best possible time to make the launch towards Mars. Unfortunately, this window only happens once every 26 months, so you would have to wait until the precise time of opportunity comes around to begin your journey to the planet Mars. Also, be sure to use the restroom and pack plenty of snacks before you go, because the time it would take you to arrive on the planet Mars after leaving Earth is right around 7 to 8 months. So let's stop there for a moment and take a look at some interesting information that I found pertaining to all of this so far when it comes to traveling to Mars. I find it really strange how Elon Musk with SpaceX, along with NASA and others, seem so sure of themselves about being able to send humans to Mars. Just based off all the information that's out there, something doesn't add up or seem right to me. Here's some examples of what I'm talking about, so follow along if you will. 438 days is the existing record for the longest consecutive space flight, and the most accrued time in space is 878 days. The average time an astronaut spends aboard the ISS is 6 months. But these are all in low Earth orbit, still within the protection of Earth's atmosphere. Here's where things get interesting. The longest time spent by a human outside the protection of the Earth's Van Allen radiation belt is about 12 days for the Apollo 17 moon landing. This is nothing in comparison to, let's say, there's 30 days in a month, times around 8 months to get to Mars. That's 240 days. That's mind-blowing any way you look at it. We're talking a huge difference when compared to 12 days currently being the longest amount of time spent outside the protection of Earth's atmosphere by any human being. Here is one other thing that seemed kind of strange to me. According to NASA, the record for the farthest distance into space that humans have traveled goes to the all-American crew of famous Apollo 13, who were 248,655 miles away from the Earth on April 14, 1970. This record has stood untouched for over 50 years. Now, it takes Mars almost 2 years to orbit around the Sun compared to the Earth's 1-year orbital cycle. And when the Earth catches Mars just right, as it finally makes a full orbit around the Sun, the two planets will align in conjunction, being the closest distance to each other. This is the launch window for Mars travel, and at its closest distance to the Earth will still be around 35 to 40 million miles away. I don't know, just seems unusual to me that the farthest any human has traveled away from the Earth is 248,655 miles, and the journey to Mars from Earth will be around 40 million miles. The numbers aren't even close. Alright, it's now time to strap in and begin the journey. Chances are right now that you would probably be taking the trip in one of these two spacecraft. And here's some information that might just persuade you to change your mind. As of right now, nothing has been developed to guarantee and allow a trip back to Earth. So in other words, it's a one-way ticket. All that decide to go are knowing and willingly choosing to do so at their own free will. Now keep in mind, as you travel outside of the Earth's atmosphere and begin your long journey of around 8 months, that there is a lot of things that could go wrong. Two major concerns that without a doubt would negatively affect humans traveling through space, again, is cosmic rays and also microgravity. The exposure to radiation from galactic cosmic rays or solar particle events greatly increases your chances of developing cancer and degenerative diseases. And on the other hand, microgravity is when things seem to be weightless in the near-zero gravity of space. This causes a number of problems, including muscles and bones in the human body to weaken. Body fluids are redistributed away from extremities, causing puffiness in the face and impacting the cardiovascular system. Your legs will weaken, shrink, and become skinnier with reduced blood flow to the lower limbs. The effects of exposure can lead to a decrease in bone density, causing bones to become more fragile and prone to fractures. Exposures can also lead to misinterpretation and inadequate responses by the brain, although in reality the overall effects through extended space travel is unknown. There are some different ideas being looked at to help better protect humans during spaceflight from the harmful effects of radiation and microgravity. One way is through stronger shielding integrated into hull design. This is an effective way to protect from most solar radiation, but defeats the purpose with high-energy cosmic rays, as it simply splits them into showers of secondary particles. One idea to help protect against cosmic rays is lining the spacecraft with water that would absorb the harmful radiation. Another idea that could help protect from both solar radiation and cosmic rays is by transmitting an electrical current through superconducting magnetic coils, shielding the spacecraft and creating a strong magnetic field around it. Unfortunately, nothing can really help with microgravity and its lasting more than likely permanent consequences, except maybe through less exposure and time in space. The only way to do this is getting to Mars quicker with a faster spaceship. This idea is being looked at, with the possibility of using plasma or nuclear-powered rocket engines, although you wouldn't want to die from the excessive amount of G-force created by going too fast. And it does seem a little scary when thinking about riding through space on top of a nuclear reactor. When arriving to Mars, landing on the red planet will yet again be another obstacle to overcome. Assuming that there is no landing pad, you would have to land on a relatively flat area on Mars' rocky terrain. There will be almost no entry friction with Mars' thin atmosphere that cannot provide enough resistance to slow a spacecraft to a slow landing speed with just a heat shield and a parachute. It will take precise maneuvers and well-calculated techniques to slow from orbital speed, which can be tens of thousands of miles per hour, to a standstill on the Mars surface. Other things to factor in for a safe landing include weather conditions, long time delays between Mars and Earth communications, and the fact that a spacecraft and all of its components must survive several months in space before making it to the surface. So as you can see, just getting to Mars safely is a hard and unforgiving endeavor with little room for error. This accounts for a large proportion of the 50-odd missions launched towards Mars to have been lost, crashing into the Martian surface or missing the planet altogether. And to date, there has only been 10 successful soft landings. Since Mars will not be ready-made for humans or any other known living things, there will be a number of steps involved to colonize and build a new life on Mars. Colonization would require the establishment of permanent structures, pressurized habitats, and suits with oxygen to breathe, the production of food, fuel, oxygen, and energy, water processing systems, compressing the atmosphere into a greenhouse, and filter out Mars soil that contains high levels of toxins, which are hazardous to human health, refine Mars soil to be suitable for growing plants, local communications through satellites, water disposal, sanitation, equipment such as resource extraction equipment, equipment for energy production and energy storage, propellant production equipment, equipment for food production, also equipment for exploring and moving over the surface. This would all be needed to help a colony grow, thrive, and survive. To reduce radiation exposure from dangerous galactic cosmic rays, humans would need to be protected by a shield or barrier. One option might be to live underground in natural caves and tunnels discovered near mountains on Mars. Since Mars is a very thin atmosphere and lacks a magnetosphere to protect humans from harmful solar radiation and cosmic rays that can easily reach the Martian surface, your time spent exploring the surface of the planet would be limited, and survival would require living in shield-protected, artificial Mars habitats with complex life support systems. You would also have to take into account for certain conditions, such as dust storms, temperatures, and reduced sunlight. Scientists have considered using Mylar disk with a diameter of 155 miles and a weight of 200,000 tons to reflect sunlight onto Mars and heat the surface. Over time, the rise in temperature would release much-needed greenhouse gases into the atmosphere. I believe the odds of Mars having water, liquid or frozen, below the surface are pretty good. One obvious reason to back this up is the rich iron oxide surface of Mars that gives the planet its rusty red color. It's just like the rust that forms here on Earth, often in the presence of water. But without a doubt, obtaining or creating a source of drinkable water is a definite must for human survival on Mars. An interesting system that is currently being tested and used by NASA is an apparatus called MOXIE. This device is equipped on the Mars Perseverance rover and will convert the carbon dioxide that makes up 96% of the gas in the red planet's atmosphere into oxygen. By pulling in the Martian air with a pump and using an electrochemical process to separate one oxygen atom from each molecule of carbon dioxide or CO2, essentially producing oxygen just like a tree. Right now, MOXIE is a little toaster-sized version operating on the Perseverance rover, but NASA has plans to develop a larger and more powerful system for a crewed mission. Another technique being proposed is obtaining and melting ice to get water, which can then be co-electrolyzed with CO2 to ultimately produce both oxygen and methane for fuel, although the ice has to be prospected, extracted, and refined before it can be used. There are proposed missions being planned to send cargo, with materials and resources needed to facilitate Mars before the first crewed mission. The idea is to have machines and robots doing a lot of the work and prepare the planet as much as possible for the arrival of humans. From start to finish, I really did my best on trying to look at this from every possible angle and to form my own opinion on reasons for colonizing Mars. Understand that what I'm about to say is based upon my willingness to question certain things with an open mind, again solely on the information that is provided to us. So, with that being said, I have come up with these three possible scenarios. Scenario number 1 is an escape to Mars with the possibility of top officials, the wealthy elite, and a select few others knowing something that we don't, and withholding information from us, like having knowledge of a devastating catastrophic event that's coming that will wipe out the population, destroy the planet Earth, and there's no way to prevent it from happening. This would give them the opportunity to analyze the situation, introduce all possible options, and propose a solution for a plan B, choosing not to release the information to the population to avoid mass chaos, riots, and worldwide panic. Instead, they have already begun a plan of action to save themselves. Scenario number 2 is we've been there, done that, and still doing it, with the possibility that humans are already living on Mars, but only carefully selected individuals that have been chosen to go because their certain role of importance or beneficial purpose. Mars missions have been in the works and taking place since back in the 1960s and 70s. So what if, for the past 50 to 60 years, people and equipment on Mars have been preparing the planet, getting it ready to the point where now is the time to expand it to the next level and start to bring in larger groups of people. Maybe this is why space agencies are so confident about getting humans to Mars really soon, because they are ready for the next phase, they know it's time, and they already know that it can be done. Scenario number 3 is it's all a big political game, with the possibility of it being nothing more than just a show of economical power and progress over another country, where the winner gets bragging rights for being the first to successfully begin and establish human colonization on another planet, with the goal of creating a permanent human settlement on Mars in order to gain political control over the planet. It might be playing out to be similar and like a repeat of the very political race to the moon in the 1960s, only this time it's the race for space and the race to colonize Mars. That's it. So until next time, thanks for watching, and as always, much love.